Okay, so now we'll go through all the 5 quiz questions, make a video out of that. So the first one, put into a standard form. Okay, well, first of all, what kind of shape is this going to be? If the coefficients of x squared and y squared are equal, then it's a circle, right? And so that tells us that we're trying to shoot for this. That's bad. Right. X minus h squared plus y minus k squared equals r squared. Right. What does hk represent? Center. What does r represent? Radius, right? So, what process do we use to take this general form of the of a quadratic and put it into a standard form? Complete the square, right? Complete the square. So remember the steps for completing the square. First, you get the x terms together and the y terms together. In this case, there only is one x term, right? There's no x to the first. So we'll have 4x squared. Right. Then we get the y terms together. They already were, but let me do this. 4y squared minus 16y equals negative 15. Right. Move the constant to the other side. Okay, what do I have to do next? Right, this y squared has got a coefficient of 4. You got to factor that 4 only from the y terms. 4x squared plus 4 times y squared minus 4y. Okay, now we can choose the number that we put in the parentheses to make a perfect square trinomial. How do we find it? Half of negative 4, negative 2. Negative 2 squared is positive 4. This number is always positive, right? Because it's a result of squaring. Okay, now what do I have to add to the other side to balance the fact that I just added something to the left? Right? It's not 4 because it's being multiplied by 4. It's actually 16. Right, so which gives us this. 4x squared plus 4 times, and you could either factor that, right? What two numbers, the product is 4 and their sum is negative 4, or just think it's half of that. Whatever the half was, y minus 2 squared, and equals 1. Now, if you got to that point, I gave you partial credit, unless you did something wrong after that. That is not in the standard form for a circle. Remember, the standard form for a circle does not have a 1 on the right-hand side. It could have a 1, right? It could have a 1 if the radius is 1, then 1 squared would be 1. But, we got to get rid of these 4s. So what are we going to do? Divide by 4, right? So this should have been x squared plus y minus 2 squared equals 1/4. Unfortunately, this is what a fair number of students do. They get to this point, and then on the next line it says x squared over 4 plus y minus 2 squared over 4 equals 1. And that's wrong. Right? You can't just because you want to put that in the denominator. Right? That's not equal to that. So don't do that. Divide by 4. It means you got the right-hand side is 1/4. In this case, what does that make the radius of the circle? One half, right? 1/2 squared is 1/4. So that's just telling you the radius is 1/2. Okay. I didn't mark, if you just got to this point and left, I kind of left alone. I mean, the truth is, we've talked about circles, and you will have to do some stuff with circles. But as far as the quiz goes, if you got that far accurately, you did all the completing of the square correct, then I gave you that. Now, for the other shapes, we spent a lot more time on them. What is the equation of the directrix? Okay, what do we mean by the directrix? And what kind of shape must this be if it has a directrix? It's a parabola, right? And is this parabola, what is the the vertex of the parabola. Yeah, the HK is -1/2, +1. Right? Does it open up, down, left, or right? It's y equals x squared. Is it up, down, left, or right? I mean, y equals x squared is the old parabola we've used ever since we did functions. And in Algebra 2, that's up or down, right? It's up if it's positive. It's down if it's negative. And this is all positive. So this one is opening up. Opens up. So I could make a quick sketch. And because the numbers involved, I'm drawing it really big. -1/2, +1. That's the vertex, and it opens up, right? Okay, so remember the parabola is defined as the set of all points that are equidistant from a point and a line. The point is called the focus, and it's somewhere in there. The directrix is the line, and it's somewhere outside of the parabola. How are we supposed to find just how far inside and outside those two things are? Yeah, this distance right here, right, is P. So we have to subtract or, use the P to go from the vertex to the directrix. How do you find the P? Right, remember, since this is a vertical, it's x minus h squared equals 4p y minus k. Right, and the 4p here is whatever is the coefficient there. So in this problem, 4p equals 4. So p equals 1. So you should be going down from this point, which is -1/2, 1. You should be going down 1. And that's the directrix. So what's the equation of that line? Y equals 0. Right, that was the answer. Y equals 0. Do you have a question? Okay. Right, sketch. Now, first of all, what kind of shape is this? It's an ellipse, right? It's not a hyperbola. It's not a parabola. If you drew the wrong shape, then, it's kind of apples and oranges wrong at that point. It is an ellipse. And what is the center of the ellipse? Right? Yeah, the center, which is HK, is 5, -3. Okay, is it opening up vertically or horizontally? How do you tell? How do you know? The biggest denominator represents a squared, right? And in this case, the bigger denominator is there. I mean, this has got a denominator of 1. So this is telling us that a squared is 36, so a equals 6. B squared equals 1, so b equals 1. Right? So we can sketch, most of this with just that information, and then we need to add the foci. So do that. 5, -3. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. So we're going to go 5, -3. 1, 2, 3, 4, 5. 1, 2, 3. Right? Then we should go up 6 and down 6. Up 6, down 6. Right? What are those 2 points called? Vertices, right? And then we should go left 1 and right 1. And those are the sides of the ellipse in the direction of the minor axis. But with those 4 points, you can sketch it in, right? Looks like that. That's not bad for a first time. Now, when it says include and label, I mean, you should, include and label. Like this point here, what is it? 5, positive 3. Right? This point is 5, negative 9. Right? If you haven't written somewhere else what the center is, then go ahead and write it, 5, negative 3. And then how do I figure out where the foci are? We have a Pythagorean theorem looking kind of thing, right, which goes like this. A squared equals B squared plus C squared. Right? And we know what the A and the B are. We know what the A squared and the B squared are, so we can solve for the C. Right? A squared was 36. B squared was 1. That was wrong. Plus C squared. So C squared equals 35. C is the square root of 35. And if you turn that into a decimal, I mean, it's got to be 5.9, right? It's just a little bit less than 36. So, we went up 6 and down 6 for the vertices. So we were going to go just a little bit inside, like right there and right there. Right, that's F and F. And remember to write their coordinates there. That would be 5 comma, negative 3 plus or minus the square root of 35. I think that's everything. Four. Okay, write the equations of the asymptotes. Okay, so what shape is it that has asymptotes? It's a hyperbola, right? Hyperbola. So let's see, what's the center of this hyperbola? Right? It's 0, 1. So HK equals 0, 1. And is it horizontal or vertical? And how do you know that? Because the first term, the positive term, is a y term, right? Y is a vertical coordinate, so this thing is definitely going to be vertical. Okay, so now we have equations for the asymptotes, right? There's two different forms. Y equals k plus or minus a over b times x minus h. Or y equals k plus or minus b over a times x minus h. Which one do we use on this one? Right. This is the one you use if it's vertical. This is the one you use if it's horizontal. I mean, if it helps, sketch a little bit of the graph, right? Just sketch a little bit. It'll become pretty clear. Now, this one, the center is at 0, 1, which is here. We should be going up 2 and down 2 for the vertices, right? So that would be there and there. So we know we've got branches of the hyperbola that look like that, right? So this distance right there, that's A, and that's 2. And it looks like the B is 1. So if we were going to draw our box, right, we would be going this direction would be the B. So the slope is A over B. Right? When it's vertical, it's A over B. It'd be the flip of that if it was horizontal. So we're using this one right there. And we know the values of everything, so just plug it in. Y equals 1 plus or minus. A over B will be 2 over 1, so that's 2 times x minus 0, which is x. And that's it. That's 2 equations. Okay. And then the last one, right, to classify. I mean, it's supposed to be an easy one for you. Remember, go down the list. What is it you look for to see whether something is a parabola? Only one square term. Okay, not a parabola. What is it you look for to see if it's a hyperbola? Opposite signs, not that. So what does that leave? Circle or ellipse? How do you tell if it's a circle? Because they're equal, and they're not. It's an ellipse.